Yes, it is permissible to bring service entrance conductors into a small through first and then into the panel using the through as a short raceway. The National Electrical Code, specifically Article 310.15b3a, addresses this scenario. This section of the code permits the use of a through as a short raceway for service entrance conductors, provided certain conditions are met. Firstly, the through must be specifically listed for this purpose. This means it has been tested and approved by a recognized testing laboratory such as Underwriters Laboratories, or UL, for use as a raceway for service entrance conductors. The listing will typically be indicated on the through itself or on its packaging. Secondly, the service entrance conductors must be installed in accordance with the manufacturer's instructions. This is a crucial requirement, as the manufacturer's instructions will specify the limitations and requirements for using the through as a raceway. These instructions will cover aspects such as the maximum number and size of conductors that can be installed in the through, the proper methods for terminating the conductors, and any specific grounding or bonding requirements. It is important to carefully read and follow the manufacturer's instructions to ensure a safe and compliant installation. The purpose of using a through as a short raceway is often to provide a convenient and compact way to transition service entrance conductors from one enclosure to another. For example, in a residential installation, the service entrance conductors may enter the building through a meter socket located on the exterior wall. From the meter socket, the conductors must be routed to the service panel, which is typically located inside the building. Instead of using traditional conduit fittings such as an LB or an LL, a through can be used to create a short raceway between the meter sockets and the service panel. This can simplify the installation and reduce the amount of space required. However, it is important to note that the through must be properly sized to accommodate the service entrance conductors. The size of the conductors will depend on the size of the electrical service, which is determined by the electrical load of the building. The National Electrical Code provides tables that specify the minimum size of service entrance conductors based on the electrical load. The through must be large enough to accommodate the conductors, without exceeding its fill capacity. The fill capacity of a raceway is the maximum percentage of the raceway's cross-sectional area that can be occupied by conductors. The National Electrical Code specifies the maximum fill capacity for different types of raceways. When installing service entrance conductors in a through, it is also important to ensure that the conductors are properly supported and secured. The conductors should be supported at intervals that do not exceed the manufacturer's instructions. The conductors should also be secured to the through to prevent them from moving or shifting. This can be accomplished by using cable ties, clamps, or other approved methods. In addition to the requirements of the National Electrical Code, local codes and regulations may also apply to the installation of service entrance conductors. It is important to check with the local authorities to ensure that the installation complies with all applicable codes and regulations. It is also important to consider the environmental conditions when selecting a through for use as a short raceway. If the through will be exposed to moisture or corrosive substances, it should be made of a material that is resistant to these conditions. For example, a through made of stainless steel or PVC may be suitable for use in a wet or corrosive environment. If the through will be exposed to direct sunlight, it should be made of a material that is resistant to ultraviolet or UV radiation. UV radiation can damage some materials, causing them to become brittle or discolored. When installing service entrance conductors in a through, it is also important to ensure that the conductors are properly grounded and bonded. Grounding and bonding are essential for electrical safety, as they provide a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The National Electrical Code specifies the requirements for grounding and bonding of electrical systems. The through must be properly grounded to the grounding electrode system. The grounding electrode system typically consists of a ground rod, a ground ring, or a metal water pipe that is in direct contact with the earth for at least 10 feet. The through must be connected to the grounding electrode system with a grounding electrode conductor. The grounding electrode conductor must be sized in accordance with the National Electrical Code. The through must also be bonded to the service equipment. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current. The two must be bonded to the service equipment with a bonding jumper. The bonding jumper must be sized in accordance with the National Electrical Code. When installing service entrance conductors in a through, it is also important to ensure that the conductors are properly labeled. Labeling the conductors can help to prevent confusion and ensure that the electrical system is properly maintained. The National Electrical Code requires that all conductors be labeled with their voltage and current carrying capacity. The labels must be durable and legible. In summary, it is permissible to use a through as a short raceway for service entrance conductors, provided that the through is listed for the purpose. The conductors are installed in accordance with the manufacturer's instructions, and all applicable codes and regulations are followed. It is important to carefully consider all aspects of the installation to ensure a safe and compliant electrical system. Always consult with a qualified electrician if you have any questions or concerns. Firstly, ensure the through is listed for use as a raceway for service entrance conductors. This listing ensures the component meets safety standards for this specific application. Secondly, adhere strictly to the manufacturer's installation instructions. These instructions will detail the proper methods for installing the conductors within the through, including torque specifications for connections and support requirements. Thirdly, verify the through is adequately sized for the number and size of conductors being installed. The National Electrical Code dictates fill capacities for raceways to prevent overheating and ensure proper conductor insulation. Fourthly, ensure proper grounding and bonding of the through and associated equipment. This is crucial for electrical safety, providing a low impedance path for fault currents. Fifthly, consider the environmental conditions to which the through will be exposed. Choose a through material that is resistant to corrosion, moisture, and ultraviolet radiation as necessary. Sixthly, ensure all conductors are properly labeled according to NEC requirements. Proper labeling facilitates future maintenance and troubleshooting. Seventhly, comply with all applicable local codes and regulations which may supplement or amend the NEC requirements. Eighthly, when routing service entrance conductors, maintain proper clearances from other objects and materials. The NEC specifies minimum clearances to prevent damage to the conductors or to other equipment. Ninthly, use approved connectors and fittings for terminating the conductors at the through and at the service panel. Proper connectors ensure secure and reliable connections. Tenthly, after completing the installation, thoroughly inspect all connections and components to ensure they are properly installed and tightened. A thorough inspection helps to identify and correct any potential problems before energizing the system. The requirements in Article 310.15b3 are designed to ensure the safe and reliable installation of service entrance conductors. By following these requirements, you can help to prevent electrical hazards and ensure that the electrical system is properly protected. It's also important to note that using a through as a raceway isn't the only option. Alternatives like LB fittings, LL fittings, or even short sections of conduit might be more suitable depending on the specific installation constraints. An LB fitting is a conduit body with a 90-degree bend and a removable cover. It's often used to make a sharp turn in a conduit run while providing access to the conductors for pulling and maintenance. An LL fitting is similar to an LB fitting but has a side opening instead of a back opening. It's also used for making 90-degree turns and providing access to the conductors. If using conduit, ensure it's properly supported and secured according to NEC requirements. The type of conduit material, such as rigid metal conduit, or RMC, electrical metallic tubing, or IMT, or PVC conduit, will influence the support requirements. The NEC specifies maximum intervals for conduit supports based on the conduit size and material. Additionally, consider the bend radius of the service entrance conductors. Sharp bends can damage the conductor insulation and reduce its current carrying capacity. The NEC specifies minimum bend radii for conductors based on their size and type. When making bends in service entrance conductors, use a conduit bender or other approved tool to ensure the bend radius is within the specified limits. Also, double check with the local inspector about the specifics of the installation because they have the final say in everything. There may be local laws and restrictions that need to be addressed, and this should all be considered.